All right, so we're going to start the final review. Okay, there's 16 questions, and it's only over chapter 6. So all the factoring that we previously did. So the first one, we have x to the 4th, x squared, and then 121. So this one looks a little bit different than what we've seen before. Most of the time we had an x squared here, and if we didn't, we could pull out something that would reduce to an x squared, and we would solve from there. However, any problem of this trinomial, 3 terms that you see, whatever the highest exponent is, if the next exponent is exactly half, then it will factor exactly the same way. Because normally you have, let me see if I can look at the next question. Nope, not that one. So like this, you have an x squared, half of 2 is 1, and most of them are like that. You got 2, 1, 0. So no matter what the exponent is, even if it was an 8, if the next one is a 4 and then we don't have any, then that would work exactly the same. It's just scaled up a little bit. So I'm going to start out with x to the 4th plus 22x, and then plus 121. Okay, so nothing can factor out. I'm going to do 1 times 121. That's going to give me 121. And then we're going to list the factors of 121. We are looking for 2 numbers that add to give us 22. There's not a whole lot of factors. I do know 11 times 11 is 121. So that's what we're going to need. 11 plus 11 gives us 121. So we're going to write 2 sets of parentheses down. We're going to, now instead of putting 1x, we're going to put x squared into both. Just separating that, giving half to both. At the back, we're going to put the 2 numbers we found, 11 and 11. The bigger number is positive. It doesn't matter which one because they're both the same, and the second sign tells me that they're both the same. So at this point, we have factored our trinomial, and it is a perfect square. So we can just write x squared plus 11, that whole thing squared, because we get that result twice. Squared plus 11 squared. All right, so the next one, we want to find the greatest common factor. So we want to find the biggest thing that we can take from each of these 3 terms. And since they all have y, we want to figure out how many y's can I take from each of them equally. And so that would end up being the smallest power of y. Okay, so I can take 2 from each. I couldn't take any more than 2 from this one. So if I factored out y squared, that would be my biggest common factor. That will leave me with 1 y to the 3rd and y to the 7th when I took 2 from each, which we can't see that. So just the greatest common factor, looking for that here, y